This video is about the nominal to numeric operator. This operator converts the values of nominal attributes into numerical representations. This is important where the data mining or processing operation that follows cannot handle nominals. For example, FP growth, support vector machines, many others. Depending on its parameters, the operator creates new attributes or changes the types of existing ones. Now, nominals do not usually have an implied ordering, so it's important to understand this so you don't accidentally create ordinals as a result of this operator. That can damage your modeling process. So the first thing we'll look at is unique integers, the coding type parameter. Then we'll look at how that can lead to unintentional ordinals being created. Then we'll look at the pre-processing model. Then we'll move on to the dummy coding type parameter. Then the effect coding type and comparison groups very briefly. So let's start with, here's a process. So as usual, it creates an example set which comes here. That gets passed to the nominal to numeric operator. Unique integers is the first thing we're going to look at. The result is here, the top output. The original is this one here, so we can compare original with processed versions. The nominal to numeric operator also outputs a pre-processing model, which is here, and I'm using apply model to apply that to another example set which I'm showing here. A copy of that's going to the output so we can look at it, and this is the end result of the apply model on that example set. So let's run it. So we're doing unique integers as the coding type. Run that. So here's the original data. 3 attributes, 6 examples, and you can see there are basically nominal values going on here. If I click on the statistics tab, you see nominal here. So what happens is, when it's run through the nominal to numeric operator, this is the output. What happens is, it considers each attribute in turn, and as it encounters a new nominal value, it gives that nominal value a number. So the first one it encounters is given the value 0. Second one it encounters is given the value 1. Next one is given the value 2. Value 8, it's seen that before, so it's 0. So you can imagine, first thing to say, this is correct, but you can imagine if someone is assuming that these nominals have some sort of ordering because value 8 is greater than value 4, after the process of nominal to numeric, in fact the order is completely changed. Now this is correct behaviour, but it's very important to make sure you understand that. And I've given these values sort of pseudo numerical values just to bring it out. If these were red, green, blue and orange, then of course there'd be no doubt. You know, there's no way you can have red greater than green, and there's no implied ordering anyway. But by virtue of processing them like this, now they do have an implied ordering, which may not be correct for this particular task at hand. So you have to bear that in mind and be very careful and vigilant for that. So then, for attribute 2 is another important point. Again, it's just working down the values it sees, value 1, value 2, 0, 1, 2. But here's an important point. When it gets to value 8 for attribute 2, it gives it the value 3 for attribute 2, and that's completely different from the corresponding number that value 8 had for attribute 1, and that is correct behaviour. So again, you've got to be a bit careful. Just because the text for a nominal value is the same between attributes, that does not mean at all that they are the same. So you can see that here, cursory glance might lead you to think that those were the same value, but in fact they're not. And that is correct, and in fact that's how it's processed anyway, that's how it's handled anyway when they're nominals. Okay, so the conversion to unique integers is easy to understand, but there are some pitfalls which we have to be wary of. While we're here, let's just quickly look at the result of applying the model. So I'm going to get rid of the original And now I'm just going to look at, this is the example set that we're going to apply a model to. It's basically the same really as the first one. I shuffled a bit, but I've slipped in a value that I haven't seen before. And the result of applying that is this. And it's worked properly, so value 8 was 0 if I remember rightly. And sure enough there's another value 8 there. Value 9 hasn't seen that, so it puts out a missing value in there. So that's worth understanding that it works, and that's how it works. Okay. Now let's go to this again, and let's do dummy coding. No comparison groups for now. Unexpected value handling, I can't seem to make that do very much, so I'm just leaving it alone. Use underscore rename, we'll come to that shortly. So let's run this now and see what happens. So now what we're seeing is, here's the original, and now I'm going to bring the result here. Now what happens is a new attribute is created for each possible permutation of attribute and value. So there are 1, 2, 3, 4, 5, I think, 5 possible values that attribute 1 can take, and this has led to 1, 2, 3, 4, 5 new attributes being created, where you can see the provenance of each of the attribute names. So where attribute 1 is value 8, then you get a 1 in the result. Otherwise it's 0, and you can see if we work down those, you can essentially see that the first example and the fourth example have attribute 1 equal to value 8, hence that's true, or 1 in this case. And you can see the end result of that is more attributes, but now these attributes are actually independent of one another, so there's no implied ordering now, and this is actually how you should really do it for things like FP growth and association rules and so on. Because if you just use the unique integer representation, then you're essentially introducing an ordinal value, an ordering to the modelling process, which may not be correct at all. So now let's just work our way through the at2 values. Here's the 1, 2, 3, 4, 5 possible at2 values. Sure enough, there they are. At2 is value 1 is that one. You can see that. Okay, so of course you're paying a little bit, it obviously needs more space to store all this, but this is what you have to do. And then you can obviously look at the attribute 3 ones here. There they are. And sure enough, there's 2 5s at the back there. There they are. Let's quickly go back to, let's just set the use underscore in name flag and see what happens. Now rather than at1 equals, it's at1 underscore value 8. Now that's important if you actually want to use these attributes in some sort of generate attribute action later. If there's a mathematical symbol in the attribute name, generate attributes can have real trouble, so there are ways around it by renaming, but you might as well just get it right from immediately. So if you want to start manipulating these later, then it's worth using the underscore option. Okay, so now let's go to effect coding, and I'll get rid of use underscore in name, and comparison groups. So I've unilaterally set at1, at2, at3 to be value 8, and value 4. So this, we'll see what this does in a moment. And this is effect coding. This also will work for the other possibility, which is dummy coding. So you can do this, use comparison groups as well there, and you get the same ones. But I'm going to go straight to the effect coding one. Let's run it. Now what you're going to see is this is the original, here's the result. Now I'm not an expert on effect coding or dummy coding, but you do need to have that possibility in certain statistical ANOVA tests, I believe. But rest assured, it does do the right thing. If I just highlight the at1 values here, I've set at1 comparison group to be value 8, so this essentially means that you get a -1 when the actual value was value 8. So you can see that's happening here and here. and it's setting it to be 1s or 0s in the other situations, and this is the correct behaviour, and I shall let that be an exercise for the reader to understand when and how to use that. But be assured it does work correctly, so that's good. Okay, so final thing, let's just put the dummy coding back. Let's take comparison groups away and run it one more time, and I'll bring up the original data and the transform data so you can see them side by side and convince yourself that you understand how it works.